Okay, Ireland and Arianda, I got your email with your questions, and I'm going to do my best to answer them using my screen right here. So you can't see me, but you should be able to hear me. The first question that you had, and you're looking at it on the screen right now, is this kind of match up the graph with the function. And if you notice this function, y equals 2 times, and then those are not parentheses, those are square brackets, right? Which is a very particular kind of function, which is called a greatest integer function. And it's also called a step function because when you look at the graph, it looks like a bunch of steps. So let's see. The greatest integer function, let me go to this right here. The basic greatest integer function is written y equals, and then it's got the square brackets around x. And if I did a table of values, well, if I did a table of values, it would look something like this. Usually, in order to make a table of values, you fill in a value for x. You get to choose the value of x, and then you calculate the value of y, right? The way the greatest integer function works is that the value of y is the greatest integer less than or equal to x. Now remember, integers are numbers like 0, 1, 2, 3, ... to infinity, but it's also -1, -2. It's all the negative numbers too. So all those are integers. So the greatest integer that's less than or equal to 0 is obviously 0, right? And clearly, if I go to 1, x equals 1, the greatest integer, which is less than or equal to 1, is also 1. But let's say that I take 1/2, right? And the greatest integer, which is less than or equal to 0.5, is actually still 0. Right? The y value is 0. That's the way the greatest integer function works. In fact, I put this in my calculator, which I've got here. And my guess is that you don't have a calculator at home. But notice up here, right? This is where I put it in the calculator. That's like putting square brackets around the x. And notice in my table of values, for x equals 0, y equals 0. For x equals 0.2, y still equals 0. For x equals 0.4, y equals 0, right? All the way up until you get to 1. And now the greatest integer less than or equal to 1 is 1. So the y value stayed the same all the way up until 1, and then it jumped to 1. And if I scroll down that table of values, notice what happens, right? It's going to keep a value of 1 all the way up to 2, and then it changes to 2, right? And if I keep going, right, it keeps the value of 2 all the way up until x equals 3, and now it changes to 3. If you look at the graph of it, it looks like a bunch of stair steps. In fact, let me zoom in on that. Zoom to enter. Right? And you can see, you can't see, there is a bar right here, right? There is a bar right there that's kind of hid by the axis, but you could tell like in between 1 and 2, right? If I'm anywhere in between 1 and 2, then the greatest integer less than or equal to that is always 1, right? Until I get to 2, and then the greatest integer, which is less than or equal to 2, is 2. Okay, that's the way this greatest integer function works. Right? Now, the one you sent me was actually this one. Let's go back to your email. It is 2 times the greatest integer of x minus 1 in the square brackets. So this will be y equals 2 times, that's outside the square brackets, x minus 1. Right, and I'm going to make myself a table of values. And for x equals 0, then if I plug in a 0 for x, I get 0 minus 1 is negative 1. The greatest integer which is less than or equal to negative 1 is negative 1. And 2 times negative 1 is negative 2. Okay, if I jump up to, let's say, up to 0.5, just to get what is going on in between 0 and 1. Right, if I put in a 0.5, I get 0.5 minus 1, which is negative 0.5. And then the greatest integer, which is less than or equal to negative 0.5, is still negative 1. 2 times negative 1 is negative 2. All right, now when I get to x equals 1, then 1 minus 1 is 0. The greatest integer less than or equal to 0 is 0, and 2 times 0 is 0. And that'll be the same until at 1.5, it'll be the same until I get to 2. Then 2 minus 1 is 1. The greatest integer less than or equal to 1 is 1. 2 times 1 is 2. So this thing should look like in between 0 and 1, this thing has a value of negative 2. Right? In between 1 and 2, this thing has a value of 0. In between 2 and 3, it'll have a value of 2. And so you can kind of see the pattern, right? It probably has a step here, it has a step here. And the only thing that's not included then, if you go back to your graph, is that your graph had, for every one of these, there was a closed circle on the left and an open circle on the right. And so if you go back again, at x equals 0, the value is negative 2, right? And it keeps that value all the way up until it gets to 1, and then it jumps up to 0. But if the value of the function at 1 is 0, then down here you got to have a little open circle saying, okay, well, that point is not on there. So every one of these steps has a closed circle on the left, has an open circle on the right. Closed circle on the left, open circle on the right. Right. So which one of our graphs looks like that? And that is this first one here. Although I have to say, these are some of the worst graphs that I've ever seen. But this is the one that shows exactly the pattern. You could tell there must be a line that goes up and down right here, but it's not showing up on the page. But in between 0 and 1, the value is negative 2. In between 1 and 2, the value is 0. In between 2 and, 2 and 3, the value is 2. So there's your stair steps. The right answer was A. Okay, your next question was, close that down. And this is very hard to see. It's mostly because of the screen. I'll bet you see it better than I see it on the screen. But this says, if g of x equals x squared minus 6x plus 3 over x plus 4, find g of negative 2. Okay, so let's go back to the slides here. Right. So when you see that kind of thing, you have g of x. Oops, that's sloppy. G of x equals x squared. Sorry, I'm running over to my computer. X squared minus 6x plus 3. Okay, where am I? Minus 6x plus 3 over x plus 4. Right? This kind of notation, g parentheses x, is called function notation. Most of the time it's f parentheses x, f of x, which you can think of as the same thing as saying y, right? F of x takes the place of y. So f of x equals 2x plus 1 is the same thing as y equals 2x plus 1. Again, this is called function notation, and you read that like you say f of x. That's how you say it to yourself, right? This here, right, in between the F and the parentheses, that is not a multiplication. So don't try to multiply. Right? All we do with this notation is we evaluate multiplication. We evaluate functions for certain values. So for example, if I said find f of 1, that means in place of the x you put a 1. So on the right-hand side, put 2 times 1 plus 1 equals 2 plus 1 equals 3. Or if I said find f of negative 3, then I say 2 times negative 3 plus 1 equals negative 6 plus 1 equals negative 5. Okay. So in your problem, you've got your g of x. I'm almost done if you have something for me. Okay. We are having to find g of negative 2. All right, so g of negative 2 equals negative 2 squared plus minus 6 times negative 2 plus 3 divided by negative 2 plus 4. Okay. So everywhere that we had an x, we put a negative 2. And now you have to simplify. G of negative 2 equals positive 4 plus 12 plus 3 divided by negative 2 plus 4 is 2. I just, and that is 19 over 2. Now, I don't recall, I got to keep going back and forth with the email, which doesn't show up on my screen. And I don't see that there's not a multiple choice format kind of question. So if you're asked the question, the answer is 19 halves. But the important thing, again, the important thing is that you are understanding this functional notation or function notation and what it means when you put a number in the place of the x. That means you put a number in place of the x, not just the negative 2 took the place of x here, but the negative 2 took the place of x here and here and here. And then you have to simplify. Okay. So let's see. I'm going to finish this video off just by showing you again where is my web page. I'm going to reply to your email with a link to this video, and then I'm going to show you my web page. So I think you can see this pretty well now. Kecoughtan High School, that's my school, right? And that's khs.hampton.k12.ba.us, right? Now, if you click on the staff right there, and you go down to math right there, then you can see my name right there, K. Callahan, and my email address and my phone number. And here's my 4 websites. And these first 2 are Algebra 2 and Algebra 2 Trig. I would recommend you probably look at the Algebra 2 Trig. There's no trigonometry going on. I have to simplify things a lot for the Algebra 2, and it could be that I'm leaving things out that you see in your book. So you might find it a little more thorough if you look at the Algebra 2 Trig. Right, there's my Algebra 2 Trig website. Now, we are working on polynomials and polynomial functions, and you're clearly not there yet. But if you notice up here, previous chapters, right, then you can find what we've already done. Right, chapter 1 doesn't, okay, properties of real numbers. I guess I don't have the title in there. I probably should have had the title. Actually, the one you would probably be most interested in, at least for the function notation, relations and functions is under chapter 2, the very first section. right? So if you watched this video right here, 2-1 video, it would explain a lot of the function notation along with some other things like domain and range, okay? So keep that in mind. Go to Kickitan, Staff, Math, Mr. Callahan. And I'm going to send you this link anyways after I finish this video. So I hope that this was helpful. It's not really much trouble for me. We'll see. I'm going to try to upload this to YouTube, and when I get the link, I will reply to your email along with the link to this video, along with the link to the website, okay? So let me know when I can help you out, because it's absolutely no problem. I enjoy doing it. Okay. Bye.